Now, good evening, everyone. We'll be doing the continuation of finite difference. So we in the last class we talked about forward difference. So we're going to be taking some examples on forward difference. So um, um, a recap of the last class, we said forward difference. Forward difference of yr is yr plus one minus yr. So and we proved some properties of forward difference. So we're going to be using the properties. We're going to be taking some examples and we're going to be using the properties. So the first, one of the properties we proved was the product. When you're looking for the product of the forward difference of two products. So we have forward difference of UR, VR, and it gives UR forward difference VR plus 1 forward difference UR. So our first example, we're going to be using this property. So the first example 1, we have forward difference of e raised power x, e raised power 3x log 2x. So if you can recall in the last class, I said that the forward difference, this formula, it's actually very dynamic. So which means this place could be ur plus 1, and this place could be vr plus 1. So it's not something fixed. So you can do this in two ways. So you can decide to pick this as your u, or you can pick this as your v. You can pick this as a u, or you can pick this as a u. So it depends on you, and that is true because we know that product of two functions is commutative. Product of this function is commutative. So now so starting, let's pick this as our u. Let's pick this as our v. So we'd have something like I'm following this property without something like u. So you have e raised power 3x forward difference log 2x plus e. Now we have log into bracket 2x plus 2h forward difference of e raised power 3x. So you can just try to simplify further. You have e raised power 3x in bracket log 2x plus 2h minus log 2x plus log 2x plus 2h. Then you have e raised power 3x plus 3h minus e raised power 3x. So basically you can leave your answer like this, or you can simplify further to the abilities. So here we have e raised power 3x. So since this is a logarithmic function, they can divide each other, and you have log in brackets 2x plus 2h over 2h. So you can close the bracket plus log 2x plus 2h. Then now you can factorize this. This is an exponential function, so I can express this as e raised power 3x dot e raised power 3h minus e raised power 3x. So just simplifying to the best of your abilities, you have e raised power 3x. So you have log. So you can split this fraction for the both of them. So you'll be having something like x over h plus 1 plus log 2x plus 2h. Then e raised power 3x is common, so you can factorize e raised power 3x. So you'd have e raised power 3 h minus 1. So looking further, I think this e raised power 3 is common to both of them. You can do e raised power 3x in brackets. You have so I would use a bigger bracket. So you would have log x over h plus 1 plus log 2x plus 2h, then e raised power 3h minus 1. So I can stop here if evaluated to well, the best of your abilities. You've evaluated to the, yeah, simplest term. So we can stop here, and you could take another approach by making this one u and making this one v. So that will be left for the viewers to attempt. So I'll be taking another example, and um, okay, okay. So my second example, we have forward difference of a quotient now. So if we want to do this, we have to recall the property of forward difference that deals with quotient, and that property is forward difference of ui over vi equals vi forward difference of ui minus ui forward difference of vi over vi plus 1 vi multiplied by vi. So using this now, here is your u, x is your u, sine 2x is your v. So you have evaluating this, you would have sine 2x forward difference of x minus x forward difference of sine 2x over sine 2x plus h plus 2h sine 2x. So basically in this example, we would not really do a lot of things to the denominator, which means we'll be leaving it like that, but our simplification will be focused mainly on the numerator. So moving forward, you have sine 2x. Forward difference of x is x plus h minus x minus x forward difference of sine 2x. Okay, so let me call this numerator. Forward difference of sine 2x is sine 2x plus 2h, continuing here, minus, okay, minus sine 2x. So I can close the bracket here. So my numerator, so I'll be having if you, upon observation, you can see that x can cancel x here. So I'll be having x sine 2x minus, now for this guy, you have sine 2x plus 2h and you have sine 2x. You have to recall a trig identity to actually simplify it. And that trig identity, I would write it on the side. So the trig identity is sine A minus sine B equals, okay, equals 2 cos A plus B over 2 sine A minus B over 2. So for this case, our A is 2x plus 2h and our B is 2x. So I'll simplify it here so I can just move on to the next line. So upon simplifying, I have, since my A is 2x plus 2h and my B is 2x. So this part, this expression will turn to 2 cos A plus B, that's 2 plus 2, that's 4x plus 2h over 2. A minus B, that's sine 2h over 2. So I have 2 cos. So I can see that I can factorize 2 here, so, and use it to cancel the 2 at the denominator. So you have 2x plus h, and here you have sine h. So yes, and moving on, you can leave your answer like this. So this can be this is x into bracket cos 2x plus h sine h, or you can decide to go one further by converting all making all the trig functions sine. So if you go one further, you can convert this to sine, and one identity that would work for this will be cos theta equals to sine into bracket 90 plus theta. Yes, and this 90 basically we express it as in terms of in radians, so this is going to be pi over 2, where this is our theta. So it means cos 2x plus h will become sine 2x plus h plus pi over 2. So from here, you would have x sine 2x minus x in brackets sine 2x plus h plus pi over 2. So, and I think you can factor out x. Yeah. So you'll be having something like x into bracket sine 2x minus sine 2x plus h plus pi over 2. So we'll simplify it to the best of our ability. So um, moving on, we'll be talking about backward difference. So let me take this one down. So talking about the backward difference operator now, which is denoted by nabla. So the backward difference operator, the general formula is just yr minus 1. So unlike the forward difference operator that the one in front will subtract the one at the back, the backward difference operator actually subtracts the one at the back. So what I'm saying is that if you have something like say 1, 2, 3, 4, 5. So for forward difference operator, if you want to do forward difference operator of yr, that is going to be 2 minus 1, 3 minus 2, 4 minus 3. Now, it's very similar to forward difference operator also, but if you want to do the forward difference operator of 3, that means you're going to be subtracting it with what is at the back. What is at the back. But if you want to do the forward difference operator of 2, you're going to be subtracting it with what is in front. So forward difference operator is just, it subtracts, it looks for what is in front and subtracts, but backward difference looks for what is behind it and it subtracts. So we're going to see more of that. So let's try to draw a table as usual. So if we have a table, so we have a table where here is xr and here is yr, and here is x1, x2, x3, x4, and here is y1, y2, y3, y4. So my backward difference, now if I do like for the forward difference, now if I do y2 minus y1 for this place, I'll be having backward difference of yr. Okay, this one will be backward difference of y1, y2, backward difference of y3, and backward difference of y4. So but this is my backward difference of yr. So if I do the same, this and this, I'll be having my backward difference of y3, but this will be my second backward difference, and this will be backward difference of y4, my second backward difference. So if I do the same, I'll be having my backward difference of y4. So that's just the technique. This, if you do this minus this, you're talking about the backward difference of y4. But if you do this minus this in forward difference, you're talking about the forward difference of y3. So that's just the relationship between them. So check some proving. So let's take this example. So one exercise, the exercise I have here, okay, I'm to prove that of okay okay I'm not to prove this. Okay, so I'm to prove that of log is equal to minus log. Okay, I'm to show that. So we just get straight to it. What is the backward difference of this? That is backward difference of log xr is log xr minus log xr minus h. So since I'm going backward, so now moving on, you have, this is a logarithmic function, so you have log into brackets, okay, xr over xr minus h. So, but don't forget, I want to prove, this is what I want to prove. So I could have taken another step here by trying to just trying to manipulate. So instead of this step, I could have factored out the negative. So I'll be having minus into bracket log xr minus h minus log xr, where if negative opens the bracket, I would return back to my normal equation. So I would have minus, okay, now they can divide each other, log xr, okay, so xr minus h, okay, xr minus h over xr. So in this case, I have minus log, so xr can divide xr, so you have 1 minus h over xr. So uh, that is my backward difference. So I've successfully proved this. So let's moving on speedily. We're going to be proving some other stuff also. Show that y r minus k equals yr minus combination 1 So want to show this, and yeah, I did not write the general formula for backward difference. Okay, so the general formula for backward difference is backward difference of this yn equals minus 1 per r n r, or this can be denoted as n combination r of y n minus r. So that is okay. Yeah, I forgot summation from r equals 1 to n, or r equals 0 to n. So this is the general formula for the backward difference. So moving on. Okay, moving on. So I want to prove this equals to this. So how do I go about that? Okay, let's start by testing. So if you do, what is backward difference of yr? That is yr minus yr minus 1. So if I make yr minus 1 subject of the formula, I would have something like switching this one here and bringing this one here, I would have yr minus, okay, sorry, backward difference. So I have backward difference of yr. So yr minus 1 equals to factorizing yr, you would have 1 minus this into bracket yr. So I think I can still keep this one here. So I know that yr minus 1 is this. Let me try for yr minus 2. So I want to do this to see if I can see a pattern. So what will yr minus 2 be? Judging from, okay, let me float with this normally. That should be yr minus 1. Okay, no, judging from this, I would have, this should be, if here is 1, so I have 1 minus backward difference of yr minus 1. Yes, so because if here is r minus 1, so if I decide to reduce this by 1 to get to r minus 2, that means I have to reduce this by 1. So I have yr minus 2 equals 1 minus backward difference. What is yr minus 1? You have 1 minus backward difference of what? Yr. So yr minus 2 equals 1 minus backward difference of what? 1 minus backward difference all squared yr. So which means my yr minus k by pattern can be 1 minus backward difference of k yr. So with this, we can see that this is shaping up to look like a binomial expansion. We can expand this binomially. So you have yr minus k equals, so using the binomial formula. So you have 1, okay, put your bracket, 1 minus k combination 1 forward difference plus k combination 2 forward difference backward difference square, I mean, sorry, plus k combination 3 minus k combination 3 backward difference plus everything in bracket yr. So yr minus k equals, when you open the bracket, you'd have yr minus k combination 1 backward difference of yr plus k combination 2 backward difference square of yr minus, and so on and so forth. So yes, we've expressed this, we've shown that this equal to this. So we're going to be using this in an example shortly now. So okay, so now where do we use this? Okay, say we're given an example like this. So we are given an example, we're given a table x, y, and we're asked to look for, okay, let me write the values of the table: 0, 1, 2, 3, 4, 5. So we have 2, 9, 28, 65, 126, and 217. So we're asked to look for the value of y into bracket minus 1 using our backward difference operator. So we have to look for this. So what do? Let's prepare a table. So we have our x and our y. So our x, from 0, we have 0, 1, 2, 3, 4, then 5. So your y, 2, 9, 28, 65, 126, 217. So your forward difference or your backward difference of y is going to be this minus this. So that's going to give you okay, let's start from here. 217 minus 126. So you're going to be having here to be 91. 126 minus 65. 61. 65 minus 28. 37. 28 minus 9. 19, and 9 minus 2, that's 7. So you can do this square. So you have 19 minus 7, that should be 12. 37 minus 19, so you have 18. 61 minus 37, you have 24. Then 91 minus 60, that's 30. So if you do this again, you have so this gives you 6, 6, 6. So if you go one further, this will give you 0, 0. So now that you have this table, you can apply this formula. So how do we apply this formula? So we want to set our value, want a value such that using this the values for um x. We want value such that we'll be able to get y minus 1. So if you have in this case I have 5. So if I do something like y equals 5 minus 6. So 5 minus 6 is going to give me y equals to y subscript minus 1. Yes, which is what I'm looking for. Or I can prefer not to use 5 and 6. I can prefer to use 4 and 5. So I can do y 4 minus 5. So once you have this, just compare it to this thing. You have y r minus k. So in this case, your k is 5. Now, your k is 5. That means you need to know, that means your yr, you need to know y4. So in this case, this is my y4. So that's 126. So we're going to be going with this. So yr minus k equals, using the formula yr. So here is y4 minus k. So k is 5. So you have 5 combination 1, 4 difference of y4 plus 5 combination 2. Okay, backward difference of y. Okay, backward difference square of y4 plus okay, minus 5 combination 3 backward difference cube of y4 plus and so on and so forth. So um okay, so for me I have y4 minus 5, okay, which is also y minus 1 equals, what is y4? So my y4 is 126. So I have 126 minus 5 combination 1, that is 5 in bracket. What's the forward difference of y4? So the forward difference of y4 is 61. So 61 plus 10 into bracket. What's the, okay, I said forward difference, backward difference of y4 and backward difference square of y4, that's 24. So into bracket 24 minus 5 combination 3. 5 combination 3 should be 10. Yes, let's check. So you have okay, so it's 10 in brackets. What is backward difference cube of y4? That's 6. So I could go one further, which is 5 combination 4, but the backward difference raised to the power 4 of y4 is 0. So I'm just picking values like this that are diagonal. If it was forward difference, I would be picking the values like this. So I would stop here. So I have y minus 1 equals 120. Okay, 126 61 times 5 as minus 305 plus 240 minus 60. So I have 126 minus 305 plus 240. Okay, let me check. Stay mistake. Yeah. Okay, so this, my answer is giving me 1. It's giving me 1. Okay, moving on. So we're going to be moving on to the next operator, which is called the shift operator. Okay, so what is the shift operator? This is just an operator that helps you shift. It's just okay. Let me just write it. So it's denoted with e. So e of yr is just yr plus 1. Now this is 1 here because what is here is raised to power 1. So if I have e of e raised to power n of yr, that would be yr plus n. So this operator is very important because it helps you to link your remaining operators to themselves. So let's just check some relationship between the shift operator and some other operators. Um so let's start from okay. So let me write. So uh, okay. So now one of the first relationship is that e equals to 1 plus forward difference. So okay, I've jumped. E equals to 1 plus forward difference. So how is this true? Um, if my e of yr equals yr plus 1. So this means okay. Let me go back. Let me use what is my forward difference operator. So my forward difference of yr is yr plus 1 minus yr. So and this is what? E of yr minus yr. So this means that if you factor out e from here. Okay, so I think this should be negative. I think this okay. Let's just flow. So um I have forward difference of yr equals to yr into brackets e minus 1. Yeah, yr can cancel yr. So forward difference should be e minus 1. So yes, e equals to 1 plus forward difference. Yes, that's correct. That's correct. So yes. So it could be this, it could be this. So this is the first relationship. So we can check another relationship is the second one is e backward difference um equals to forward difference. So let's do it. So we have starting from here you have e um yr. So this is e into bracket yr minus yr minus 1. So e yr. Okay, so what is okay? Good. So what is EYR? So EYR is let's move on. Minus EYR minus 1. So this is you're shifting it by 1. So that's YR plus 1. So this is minus YR, and this is forward difference. So I've shown that this is equal to this. So let me try to let me go the other way around. So if I have backward difference of E equals um backward difference. Okay, let me add my R. So backward difference of E equals backward difference of yr plus 1 minus yr minus yr. Okay, good. And backward difference of this is yr plus 1 minus yr. So this is yr plus 1 minus yr and minus into bracket yr minus, okay, so supposed to share it. Yes, so yr minus 1. So for this case, you have yr plus 1. Okay, so opening the brackets, you have minus yr minus yr plus yr minus 1. Okay, so you'd have yr plus 1 minus 2yr plus yr minus 1. Oh, no. So what I want to show is this being equal to this. Okay, so I think I have skipped something from here. So showing that this shift operator is this. Oh, what an error. So from here, I was supposed to show that the shift operator is just yr plus 1. So and what is the backward difference of yr plus 1? That's yr plus 1 minus yr, and this is actually what? Forward difference. So I've shown that this is equal to this, and I've shown that this is equal to this. So this and this are equal to each other. So yes. Then moving on to the central difference operator, and I'll be explaining them using my shift difference operator. So I think I can take this down. So my central difference operator. So my central difference operator is just yr plus half minus yr 1 minus 1 over 2. So something like this. So we are adding our r, we're adding it by half, and we're removing half from it. Yes, on this side and on this side. So I can literally express this like this: equals e raised power half of yr minus e raised power minus half of yr. So yes, this can, which means my central difference is e raised power 1 over 2 minus e raised power minus 1 over 2. So we could do that. So this is another relationship between the shift operator and other finite difference operators. So let's look at the averaging operator. So the averaging operator noted by this. So the averaging operator yr is yr plus half plus yr minus half over 2. So relating this to my shift operator, I have averaging operator yr equals shift operator 1 over 2 plus e raised power minus 1 over 2 over 2. Okay, yr. So which means averaging operator is equal to this 2. So basically, so let's still check out some other relationships. between them. So we'll be proving some relationships and we'll wrap the class up. So um so the first one we're going to be proving e raised to power n over 2. So I can call this a problem. Okay, I've lost count. So e raised to power n over 2 show that e raised to power n over 2 equals minus 1 over 2. So how do I do this? Okay, so I think I can go from this side and end there. Yeah, I think I can do that. So solution. So let's start from the most complicated side. So what is this? This is this as we've earlier expressed, and this is this. So I can do right hand side. I have this equal to plus over 2. Yes, and equals to. So if I decide to make this one over 2, so I'll be having over 2. So subtracting both of them, you'd have minus equals e raised to power 1 over 2 plus e raised to power minus 1 over 2 minus over 2. You have the same denominator, so you have e raised to power 1 over 2 minus, okay, so you have minus e raised to power 1 over 2. Then you have plus e raised to power minus 1 over 2 plus e raised to power minus 1 over 2. So everything over 2. So this being okay, good. Exactly what I was looking for. So here supposed to be negative. Not as much. So this can cancel this. So I have 2 e raised to power minus 1 over 2 over 2. So you have e raised to power minus 1 over 2. And okay, yes. So and this one can actually denote n because my n for these guys was actually what? 1. But if I decide to use n here, that means all these guys will become n, 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 and my final answer here I'll be arriving at n. So I'll pick the next one. So it's not a must we actually cram all this stuff as identities, but just know that you can actually work them out using your shift operator. That is the most important part of it. So rubbing this off, we'll move to some other identities. So or some other proving. So we have to show that yeah. So we have to show this, and what can we do? Okay, I think the best strategy here is to actually solve both sides till you get to something equivalent. So I will pick, let me pick the right hand side first. So for my right hand side, I have my 4 difference operator. Or let me pick my left hand side. Yes, let me pick my left hand side first. So my left hand side, from what I've proved here, I know that e raised to power 1 over 2 plus e raised to power minus 1 over 2 over 2 multiplies e raised power 1 over 2 minus e raised power minus 1 over 2. Okay, so multiplying both of them, this is difference of two squares. So I have e, and I have minus e raised power minus 1 over 2. So I want to successfully prove that this should be equal to this. So I think, let me stop here for my um, right hand side. So let me go to for my left hand side. Let me proceed to my right hand side. So we do have okay, so what do I know about four difference operator? So I know that my four difference, I know that E equals to 1 plus 4 difference, or 4 difference equals to E minus 1. Yes. So using this, okay, let me check that. I think I have done it somewhere. Okay, so using this, I can put it here. So I'll be having something like 1 over 2 um, multiplied by e raised power minus 1, e raised power, okay, e minus 1 multiplied by e raised power minus 1 plus 1 over 2 e raised power 1, e minus 1. So multiplying this, you'll be having 1 over 2 e times this, that will be 1 minus e raised power minus 1 plus 1 over 2 e raised power minus 1. So half is common, so you have 1 minus e raised power minus 1 plus e minus 1, everything over 2. Okay, so this can cancel this, so I have e minus e raised power minus 1 over 2. So I think I've shown that the left hand side is equivalent to this, and the right hand side is equivalent to this. So definitely this is equal to this. So left hand side equals to right hand side. So just take two more examples and two more provings, and we'll wrap it up. So let's see. I have show that 1 plus, wow, equals to 1 plus. So how do, so I think I have to record a lot of stops. Like since you know that your central difference is e raised power half minus e raised power this. So this implies that if when you square it, you'll be having e raised power. If you square both sides, you'll be having e raised power. Okay, e raised power 1 minus 2. Yes, minus 2 plus e raised power minus 1. So for my averaging operator, you know that e raised power half plus e raised power minus half over 2. This is my averaging operator. So if I square this guy, if I attempt to square it, okay, let me square it on the next line. If I attempt to square it, you'll be having e raised e plus 2 plus e raised power minus 1 over 4. So I think I can combine these two and put it here. So I'm starting from my left hand side. So yes, starting from my left hand side, so I will multiply these two. So I have root of 1 plus this multiplied by this. So I have e plus 2 plus e raised power minus 1 over 4 multiplied by e minus 2 plus e raised power minus 1. So wow. So opening the brackets. Okay, collect. Finding LCM. So I have finding LCM. I have 4. So I think I have to employ the use of a rough sheet. So okay, so from here I'm going to express the product of this here. So multiplying them, you have E multiplied by E, so that's E square, then E times minus 2 minus 2E, E times E raised to power minus 1, that is plus 1. So 2 times E plus 2E, 2 times minus 2, 2 times minus 2, that's minus 4, 2 times E raised to power minus 1, that's plus 2E raised to power minus 1. So E times E raised to power minus 1 times E, that's plus 1, E raised to power minus 1 times minus 2. So you have minus 2E raised to power minus 1, then E raised to power minus 1 times E raised to power minus 1. So you have E raised to power minus 2. So looking at those things that can cross out, you see that this can cancel this. Yes. So what else can cancel? Um, okay, so this can cancel this. So I have E square plus 1. Okay, 1 plus 1, 2. Good. So minus 4, that's E minus 2 plus E raised to power minus 2. So I have this. So I'm bringing this here. So I have my root equals 1 plus E square minus 2 plus E raised to power minus 2 over 4. So looking for your LCM, you have 4 plus E square minus 2 plus E raised to power minus 2 over 4. Okay, so I can rub this off. Now, you can, okay, so this root is this 4, the denominator is 2. So I have square root of E raised to power 2 plus 2 plus E raised to power minus 2. So, and this is over 2. So this looks like an identity. This looks like a square plus 2ab plus b square, where my a is e and my b is e raised to power minus 1. Yes, so this can be compressed into square root of e raised to power, okay, e plus e raised to power minus 1 all squared over 2. So square can cancel square root. You have e plus e raised to power minus 1 over 2. Okay, so since I know that this is this, and yeah, so I think let me stop here for my left hand side. So proceeding with my right hand side, I have finding the LCM. I have 2 plus this square over 2, and what is central difference? You have 2 plus e minus 2 plus e raised to power minus 1 over 2. So 2 can cancel 2. Beautiful. So e plus e raised to power minus 1 over 2. So since you've shown that the left hand side and the right hand side is equivalent to something, then yeah, we've successfully shown that this is equal to this. So left hand side equals to right hand side. So, and